Welcome to this unique presentation. I am the host Narresh Krishna. Today we will be talking about the ubiquitous board ESP266 and 8285. 8285 is a variation of 8266. Only difference is it has a flash drive and the board looks different. Anyway, the basic knowledge on board about the board and its uses are: it's a venerable multi-purpose board, or MC, or microcontroller unit, which operates under the code name NOD-MCU. It's succeeded by the ESP32 family of boards. This chip was originally an inexpensive looking chip with no modules attached. It became it attained meme status and was basically like, hey, it can be used for anything. So let's use this board. These are images of both chips, as I said. Since this is ESP8266, while this is the ESP8285, which is the same chip, similar ports, but it can be inserted in many more modules. The ESP8266 has a processor of L16 32-bit RSC microprocessor core, which has a tensilica diamond matrix. It's a standard 106 micro running at 80 or 160 megahertz. Memory is 32 kilo. It has 32 instruction RAM, 32 instruction catch RAM, kilobytes user data RAM, 16 kilobytes ETS system RAM, and external QSP flash up to 16 millibytes. Megabytes is supported. 512 kilobytes to 4 millibytes typically included. It definitely needs a type 1 module, otherwise it can't take voltage up more than 3.3 volts. It has 17 GPU pins in which you can directly connect it to a breadboard or various other modules. It has I2 software implementation and I2S interface with DMA. A UART on dedicated pins plus a UART can be enabled on GPU2, which enables for more connectivity. It has a 10-bit ADC, successor approximation ADC. Board specifications. These are the original board specifications before it became popular and made commercialized by a third-party company. This is the last company-made board, after which we get into the popular ones. The description of what the active pins include, you can read it and go through. The active pins include the GPC and the ADC pins which we can attach external drives to the motherboard. The pitches is spaced between the table above and the two tables if you attach to a breadboard. If you notice, a breadboard has particular sets of pins, right? It's basically which pin you can attach to which pin. Some boards you can't attach an entire row of pins. You have to leave it hanging out. The second board is smaller, so you can attach it fully on a motherboard. The first board is not small enough, so you can't attach it directly. That's what he gives an extended but brief description about. This is a continuation of about it. The form factor also describes the module packaging, which is basically the shape of the board, how you can arrange modules on it, how you can increase your connectivity, how to code on it, etc. etc. AI thinker models. This is what popularized the board, since board is becoming popular at one point, so they were like, screw it, we need more. This is the first series of models where ESP8266 by third-party manufacturer, AI Thinker, and immensely widely available. The most commonly used ones are ESP1 and ESP12, 12E and other models. They form a workable development system that require additional components. Especially you need an adapter for the serial TTLs. It's also called a USB to UART bridge, an external 3.3 volt. As I said, it can only go up to 1.13 volts or sometimes 3.3 volts. If it goes beyond that, if your input power goes beyond that, you're screwed. As I said, contemporary chip. This can push it up to 5.5 volts input. When project development is complete, these components are not needed. It's only needed before you code. When you code the modules. Flash memory sizes apply to certain modules. Also, the modules are separate chips themselves. These are the names of the chips, and notes are given whether it depends on a flash drive or not. Also, the dimensions are given and whether it's shielded or not. Shielding is important, especially because you want to know whether if that don't interfere with other chips on the radio. If the radio waves, communication via radio waves don't affect other chips. You can also communicate via infrared waves. That's a secondary topic. These are the secondary variants of these boards. As you see, the ESP1M is especially and uses ESP8285. This is the common one with a 1 millibyte spark type built in. And these are the other variants. FCC approved means it's not it's shielded but not approved by the FCC. It's basically a regulatory body for regulating the air waves, etc. So that the radio waves from one device don't interfere with the other. And these are the sockets which have difference in it. It's why you plug in the input sockets, etc. As I stated, ESP12E is the most commonly used. 12F and S are special variants, as stated here. 12E is especially used because it has a large storage area, whereas 12 is the base model. These are ESP13 and 14, 15 is a separate one. I heard nobody uses 15, so it's not mentioned. The other variations of the board, because people are like, it's good, we want to make our own ones. These are the uses of the board. Uniclock, MC unit for IoT or Internet of Things, IR sensor models with Bluetooth connect, LED circuits, anything which your imagination comes use. What is ESP8266? The model enables microcontrollers to connect to it for 2.4 gigahertz Wi-Fi. Basically, Wi-Fi is divided into many spectrums on which devices can connect. On 4G spectrums, 2.4 is the common one. On 5G, it's 5 gigahertz. Sometimes 2.4 if the device can connect. Using the connection protocol IEEE 8.802.11 BGN. It can be used with ESP80 firmware to provide Wi-Fi connectivity to external host MCUs like other microcontroller units, or it can be used as a self-sufficient microcontroller unit by running a RTOS-based SDK, which is like the Arduino, IDE, apps, etc. The successor of chip is ESP32-C3, which is an advanced version of the same chip but with input features such as the built-in. It's also pin compatible with the predecessor, meaning you can stack both chips. It's based on a single core RSB 32-bit CPU with a clock speed of 168 MHz. It includes 400 kbps of SRAM, which is the superior version of CRAM or other types of RAM, and 384 kilobytes of RAM storage built in. Anyway, thanks for watching. Learn to code responsibly.
Thank you.